Hello students and welcome back. I think you all are safe. So let's get started in today's class. In today's class we are going to discuss about the factors and the multiples. Okay, so what are factors? Factors of a number are those numbers by which the first number can be divided. So let's give an example. If we write a number that is 12, we know that 12 is divisible by 2, 3, 4, 6 by such numbers. So 12 is divisible by 2, 3, 4, 6 and also by 12 and also by 1. So 12 can be divided by all these numbers. So all these numbers are factors of 12. So I think you understand what is a factor. Like if I give another example like 10. So 10 is divisible by 1, 2, 5 and 10. So these are the factors of 10. Got it? Okay. So in case of factor, when we are going to start the factor, we have to learn few topics. That is, few terms we have to learn. That is, first is prime number. What are prime numbers? Prime numbers are such numbers who have exactly two factors. Not more than that, not less than that. Exactly two factors, those are prime numbers. Means the number which has exactly two factors, that is 1 and the number itself. So if I write a number 7, you can say the number is not divisible by any number except 1 and the number itself. So it has exactly two factors. All the numbers has these two factors, that 1 and the number itself, because every number is divisible by 1 as well as by the number itself also. So in case of a number, if it has only two factors, then it is a prime number. Okay, so similarly if I write 9, so 9 has more factors like 1, 3 and 9. We can see that 9 is divisible by 9 and 1 always, but there is another factor 3. So it is more than two factors. So whenever a number has more than two factors, that is not a prime number. What is this called? It is called a composite number. It is called a composite number. Okay, so any number having more than two factors is a composite number. Okay, now let's see that what is twin prime and coprime. Okay, so first is twin prime. What are twin prime numbers? Twin prime numbers means if two prime numbers differ by 2, that means if the difference of two prime numbers is 2, those two prime numbers together we call the twin prime numbers. Like if I give example, 3 and 5, both are prime numbers because 3 has the factors 1 and 3 and 5 has the factors 1 and 5, nothing else. So 3 and 5 are called twin prime because the difference between these two is 2. Similarly, if I write another example like 11 and 13. So 11 has exactly two factors, that is 1 and 11, and 13 has two factors 1 and 13, but the difference between these two is 2. So whenever any two prime number differ by 2, that is twin prime. So these two numbers togetherly called twin prime numbers. These two numbers togetherly called twin prime numbers. Okay. Another is coprime. Coprime numbers. Coprime numbers are, it is also a pair of numbers. If a pair of number does not have any common factor, means, let's give an example. Suppose 6. 6 is not a prime number. It has the factors, that is 1, 2, 3 and 6. So it is not a prime number because it has more than two factors. I write another number like 10. So 10 has factors 1, 2, 5 and 10. So we can see there is a common factor 2. But if any common factor is not present in these two numbers, then we should call it as a twin prime number. Like, I'm giving another example like 14 a number, another number that is 2639. 14 and 39. So the factors of 14 are 1, it is divisible by 2, it is divisible by 7 and 40. And 39 is divisible by 1, 3, 13 and 39. These are the factors. So we can see both the numbers are composite number, they are not prime. But they do not have any common factor except 1. 1 is always common. Okay. So except 1 there is no common factor. So these two are togetherly called the co-prime numbers because they do not have any common factors. That means they are prime to each other. Okay. So we have seen a lot about the prime numbers, composite number, twin prime, co-prime. Now let's see how to find the factors of a number. How can we find the factors of a number? So there is basically two methods. That is, the first method we say it is prime factorization method. And prime factorization method involves two techniques. First is division method, and another is factor tree method. So first is division method. Do you remember the division method is the base of the factorization. So what is division method? Let's see. So for that we need a number to be factorized. Suppose we are taking a number 24. Okay. So how to factorize it? Simply divide it. This is the way of factorization. Here this is a simple division. This is the dividend. This is the divisor. We have to start with the smallest prime number. We know the smallest prime number is 2. So you have to start from 2. As long as the number is divisible by the smallest numbers, we have to continue with the smallest number. We cannot jump to the higher number. That's why it is called the prime factorization. Okay, we have to divide by the prime numbers only. So by 2 it is divisible. So we are getting the result 12. Again by 2 it is divisible. We are getting the result 6. And again we can divide it. So we are getting the result 3. So our division is completed. No more division is possible here. So now we are going to write the factors of the number. Okay. So this is the factorization. So this is the process we generally say. So we can say, right, 24 is factorized in this way. This is the factorization. So this can be the process is called the division method. Another method is there, that is factor tree. Actually factor tree, whenever you are using factor tree, we have to use this division method at the background. Like in a factor tree, how do we write? We write it as a binary tree. Like 24 is divided into two parts. Which two parts? 2 and 12. So 2 and 12. Further, 12 is divided into two parts, that is 2 and 6. So that is 2 and 6. Again 6 is further divided into two parts, that is 2 and 3. Okay. So this is our factor tree. This is called the factor tree. And what are the factorization? The last nodes of the tree, that is 3, 2, 2, 2. So again we can write 24 equals to 2 multiplied 2 multiplied 2 multiplied 3. So this is the factor tree method. This is the factor tree method. Using this factor tree method we can factorize any numbers. But as you can see, whenever we are using factor tree method, we have to use this process at the background. Then our calculation will be much easier. Okay. So these topics already you have learned in earlier classes. Again I have discussed all this. Now let's get started with the HCF. HCF means highest common factor. So HCF, that is highest common factor. So how to find the highest common factor of a number? Of not only a single number, we need two numbers. We can find the HCF with several numbers, 3, 4, 5, as we can like, as many we can like. So let's start. So the first method of finding an HCF is listing factor method. So how to do it? We're taking an example 12 and 18. and we are factorizing the 12, that is 6, that is 3. So 12 can be written in multiple ways. So by 1 multiplied 12, we can write it 2 multiplied 6, 3 multiplied 4, and nothing else. So these are the factors of 12. So the factors of 12 are 1, 2, 3, 4, 6 and 12. Similarly, if we do the factorization of 18, we are getting 9, and by 3, 3. So 18 can be written as 1 multiply 18, 2 multiply 9, 3 multiply 6 and nothing else. So these are the factors of 18. So the factors of 18 are 1, 2, 3, 6, 9 and 18. So what are the common factors here? So the common factors are, that is 1, 2, 3 and 6. So which is the highest one? That is HCF is the highest one. HCF means highest common factor. So the highest factor is 6. Okay, so this is how we can find the HCF using the listing factor method. Okay. The next is by prime factorization. The first method we have learned, that is by listing factors. First we listed the factors, then we found the HCF. Now by prime factorization. So how to do by prime factorization? Let's take another example like 16, 20 and 36 or 32 this time. 2. Okay. So by prime factorization. So prime factorization method you remember. So we factorize each the number. That is 2, 8, 2, 4, 2, 2. And 20, 2, 10, 2, 5, 32, 16, 8, 4. So this we have factorized. So 16 can be written as 2 multiply 2 multiply 2 multiply 2. 20 can be written as 2 multiply 2 multiply 5. And 32 can be written as 2 multiply 2 multiply 2 multiply 2 multiply 2. Now we have to find the common values. So we can see there are many 2's here present. So the least number of 2 present here, that is 1 and 2. Here also we are taking 1 and 2. Here we are taking 1. These 2, there are no 2 times 2 present here. Here also 3 times present, but there is no extra 2 present, so we cannot take it as a common. So our HCF is 2 multiplied 2, that is equals to 4. So this is the method prime factorization. Remember the method names, because the question it may be asked that find the HCF using this method. Then you have to follow the exactly same method. You cannot use another method. But if it is not mentioned, you can use any method you want. So there are more 2 methods of finding HCF. Okay, let's solve this one using another method. That is by division method or the continuous division method. So for the continuous division method, we have to defactorize. We have to do the prime factorization together, all 3 together. So now we have to find a number by which all 3 numbers are divisible. So you can see that all these are even numbers. So by 2 it is easily divisible. So 8, 10 and 16. Again by 2 it is divisible. So it is 4, it is 5, it is 8. Now 4 and 8 are again divisible by 2, but 5 is not. So we cannot proceed. We have to stop. And the HCF is these numbers. The product of these numbers. So HCF is 2 multiplied 2, that is 4. Got it? So this is how we are solving the HCF using the continuous division method. Continuous division method. Okay, so this is the continuous division method. And the last and my favorite method is long division. Long division method is basically used for large numbers. Means if a number is three digit number, we have three numbers. Then we have to find the HC. This process is very much helpful. Like if we have three numbers, the same number like 16, 20 and 32. How to do the continuous long division method? Long division method, we have to choose the smallest number and the second largest number. So second largest number is this. We have to continue the division. 16, 20. 16 on the 16, 4. Always remember, whenever we got a remainder, with that remainder, the previous divisor should be divisible. So by this number, we are going to divide this again. So 16. So 4 4s are 16. So we will stop now. But how long we will continue? We will continue until we are not getting the remainder as 0. Okay. So now this is our divisor. By this number 20, we are doing the division and ultimately got this divisor. So this divisor we are going to use again. This one only, not this, not this, not this, only this one. Remember, by 4 again we are dividing the remaining number, that is 32. So 4 8s are 2. So this is our x. So the last number by which it is divisible, it may continue like this way. Whenever it is divisible, the last divisor is the x. So this is for very small number. Let's try a large number. Okay. So for a large number, what we need? We need some large number. Suppose take it 175. Okay. 250 and 525. So these three numbers. If we do using the other three methods, then it will be very long. So for that purpose, this method, using the long division method, it becomes very easy. So let's see how to do. Again, the same procedure using the smallest number to the second largest number. So 175 ones up, 5, 75 and this is. Again by 75 we are dividing 175. 75 2s are 150. So we are getting 25. Again by 25 this number, not this number. The last divisor we have to divide. 25 to 25 3s are 75. So this is the divisor till now. So with this divisor again we are going to divide this number. So by 25 we are going to divide 525. So 25 2s are 50. 25, 125. So this is our last divisor. So HCF is 20. Now you see which method is much easier to use. The listing factor method, prime factorization method, continuous division method, or my favorite, the long division. I think you understand all the topics of today. That's all for today. Thank you and have a nice day.